This video is going to cover section 1.2 on data sampling and variations in data and sampling. This is actually going to be the first video of 3. I broke this slideshow into 3 because it's a little bit long, so I thought that 3 videos shorter were better than one really long one. So we're going to talk about data. We already talked about it a little bit, but data may come from a population or a sample and are generally denoted by lowercase letters like X or Y. Data can be qualitative, which is categorical, or quantitative. Qualitative data are the result of categorizing or describing attributes of a population. And quantitative data are always numerical and result from counting or measuring attributes of a population. All data that are the result of counting are called quantitative discrete data. These data take on only certain numerical values. 1, 2, 3, things that you can count. They might be bigger numbers than that, but they're discrete data points, discrete numbers. Data that are not only made up of counting numbers, but that may include fractions, decimals, or irrational numbers are called quantitative continuous data because they're not separate pieces of data. They can be sort of anywhere along the number line or along a spectrum, for example. So we have a couple of examples from our textbook. I'm going to see if I can can't move my face in this video. The data are the number of machines in a gym. You sample 5 gyms. One gym has 12 machines, one gym has 15 machines, one gym has 10 machines, one gym has 22 machines, and the other gym has 20 machines. What type of data is this? It's quantitative discrete because the numbers, you can't have parts of machines, right? So you can't have fractions or decimals, and you're going to have real numbers, integers, 12, 15, 22, etc. The next example, try at 1.6. The data are the areas of lawns in square feet. You sample 5 houses. The areas of the lawns are 144 square feet, 160 square feet, 190 square feet, 180 square feet, and 210 square feet. What type of data is this? Now you might want to say, again, quantitative discrete because they gave us whole numbers for these, but if you think about a lawn, it could be sort of anywhere in between those numbers. It could be 144.5 square feet or a quarter. You can have a decimal or a fraction in this case. So this is actually quantitative continuous data. Sometimes you have to think about it a little bit more because the data they give you might seem to be one type. But if you think about it in general, you realize that it could be also in between those numbers. Try at 1.8. The data are the colors of houses. You sample 5 houses. The colors of the houses are white, yellow, white, red, and white. What type of data is this? So it's not numerical, so it's not quantitative. It's qualitative. Also categorical is another word we use for it. You might collect data as numbers, but report it categorically. One example is a student's grades, which are recorded throughout the term as quantitative discrete data, but reported at the end of the term as categorical data, A, B, C, D, or F. You could also argue that that would be quantitative continuous data because you could have an 85.5. But the point is that if you can even, you have it, it's numerical quantitative data, but you can report it categorically. You can also go the other way and talk about, getting qualitative or categorical data, like the colors of houses, but then talking about it in a proportion. What proportion of the houses are red? So sometimes the way we talk about it after we've collected it is different than the actual kind of data we collect. Try at 1.10, the registrar at State University keeps records of the number of credit hours students complete each semester. The data he collects are summarized in the histogram. The class boundaries are 10 to less than 13, 13 to less than 16, 16 to less than 19, 19 to less than 22, and 22 to less than 25. And that might seem like a lot, like that was a lot of words, but it's important to know that your data, that first bar includes 10, but not 13. and the second bar includes 13 but not 16. You can't have 13 be in both, so you have to be specific about which bar it belongs to. But what type of data does this graph show? So it's the number of credit hours completed per student. All right, so how many credit hours can you do? You know, obviously 10, 13, 16. It's quantitative discrete. Again, you might argue that this could be quantitative continuous if you potentially have a half credit, but you could even then say that that is discrete because it's just 1, 1.5, 2, 2.5, etc. It's not all the numbers in between. So there's lots of ways to display qualitative data. Tables are a common one. They display counts, which are also called frequencies, and percentages or proportions, which are relative frequencies. So here is a table with De Anza College and Foothill College, and it talks about the number of full-time, part-time, and the total number of students, and it gives us the number in each category, and then the percent as well. So the numbers are the counts, those are the frequencies, and then the percents are the proportions or the relative frequencies. And displaying percentages can be particularly important when comparing data that has different totals, right? So the total number of students at De Anza is over 22,000, but at Foothill College, it's over 14,000. So those are different amounts, different totals, but the percentages then make it easier to compare versus the frequencies or the number of students in those categories. So what does it mean to have 9,200 full-time students at De Anza? Well, that's 40.9% of their students. That's easier to compare to the 28.6% of full-time students at Foothill College. Graphs are another useful way to display data. Pie charts use wedges to represent categories that are proportional in size to the percent of individuals in the population. So these two pie charts use the data from the previous table, and it shows us the percent of full-time and part-time students at both De Anza College and Foothill College, and it's just a visual representation of that information, which sometimes can be really helpful. You can tell by the numbers, but obviously 71.4 is a larger percentage. You can see with that larger pie wedge that it's a bigger percentage at Foothill College versus De Anza College. Here's two more examples of pie charts, and the one on the left-hand side is alphabetical. So this represents the ethnicity of students, and so Asian, Black, Filipino, Hispanic, Native American, Pacific Islander, white, other, that's alphabetical, and the pie chart goes in order of that alphabetizing of the categories. The one on the right-hand side is actually going numerically. So it has the largest percentage Asian and then the next largest white. And so the pie wedges are decreasing in size as you go clockwise around the pie chart. So it's two different ways to represent it, and you always want to think about when you're representing your data visually, is it saying what you want it to say? Is it allowing the person looking at your data to see what you want them to see? So two examples. So we're going to create a pie chart in Excel. And this is data that recently at a cat show, there were the following numbers of cats and breeds: 99 Persians, 30 Abyssinians, 66 Balinese, 41 Manx, 106 Siamese. So our first step, we're going to enter each label and the associated data into two columns as shown. We're going to then select the two columns of data. We don't want to include the title row. And then we're going to click Insert Chart from the top menu and pick the pie chart. Across the top, we'll see different formats. We're going to pick the one that you prefer. There's a bunch of different ways you can do it. And so again, how do you want your data to be seen by the viewer? You can edit the different parts of the chart by double-clicking on them. And now we're going to try it. We're going to use your laptop and launch Excel, and we're going to try this example. Now in Canvas, I have an Excel sheet for you to look through. And that first tab is going to be the data we want for this example.
So
in Excel, in that first tab, it says Excel pie chart example. So we are going to make a pie chart out of this data. So we have our titles up here. We have the types of cats here. We have the amount in show. And so we are going to highlight the data. Now, it is currently, if you notice, it is sorted alphabetically: Abyssinian, Balinese, Manx, Persian, Siamese. So if I highlight the data and I go up here to the Insert menu, I have a bunch of options. There's recommended charts, and then there's all these different types of charts. So I wanted to do a pie chart, so I'm going to click this here, and there's a couple of different options. What I have in the video is the 2D pie chart, but then there's other options too, the 3D one, the donut, but then they also have all these different pre-set up formats for you, so you can click through and see which one you like best. Again, how do you want to present your data? How do you want the viewer to see your data? So this is different than the one I have in the video, but just to show you, here's one option. Now I can go in here and I can double click on the chart title and I can say types of cats in show. I like that. I can also click on different things, and what I did just then is I right-clicked. I clicked on one of those pie wedges, and then I right-clicked on it, and then I can do different things. I can change series chart type. I don't want to do that. I can change. I can even I can move things around if I want. Now I'm going to do Control Z, and that's going to take me back. Undid what I just did. But I just wanted to show you that there's all these different things that you can do. You can change the color. You can change the outline. Maybe you want this one to have, it's hard to see, I think the purple, but it did change from green to purple, so you can do it however you like it. Now, so again, this one was alphabetical. If we wanted to make it so that it went in order from largest category to smallest category, like we saw. Here in the data, I'm highlighting the data. I'm including the names and the numbers. And then I'm going to go up to the menu again, and I'm going to choose data. And I'm going to sort it. And now these, it would do lowest to highest. This would do highest to lowest, but that uses your first column on the left-hand side. And I don't want to, it's already sorted that way. I want to sort by column B, the numbers. So I'm going to click on sort. It gives me a pop-up box and says, what do you want to sort by? Well, I'm going to go over here and I'm going to say, I want to sort by column B. Do I want to do smallest to largest? I think I want to do largest to smallest. When I click on OK, notice our highlighted columns change. Notice the chart changes automatically too, which is kind of cool. So now Siamese is our largest category. So that's here, this blue, there's more than one blue, but the darker blue is the 31%. And my battery's dying. So I am going to pause this here. Bar graphs use bars to represent the data. The length of each bar is proportional to the number or percent of individuals in each category. So here again, that data from De Anza College and Foothill College. So instead of the pie chart that had the wedges showing the percentages, this is showing us the frequencies. And so, at De Anza, there were 9,200 full-time students and 13,296 part-time. So this bar graph uses the frequencies, but because it's visual and we're comparing De Anza and Foothill side by side, again, it gives us a little bit of that ability to compare to see how much bigger those counts are of the different categories at the different schools. Bars can go vertically or horizontally depending on how you want them to look. These are going vertically. You can have bars that go horizontally. And then a Pareto chart has bars that are sorted by numerically, so in descending order. So this is not a Pareto chart, but that is one kind of bar chart that we're going to take a look at. If data can be in more than one category, you may get percentages that add up to more than 100%. In these cases, you can use a pie graph, you can use a bar graph, but not a pie chart. So in this bar graph, you can see that students under the age of 25 are 61%, intend to transfer is 48.6%, full-time is 40.9%. Those aren't going to add up it's going to add up to more than 100 because you could be under 25 and intend to transfer. You could have students in more than one category, which is why you have those percentages not adding up to 100. So you can't use a pie chart for this display of the data. Pie charts need percentages that add up to exactly 100%. So this table represents the ethnicity of students at De Anza College, fall term 2007. And so this is what the ethnicity charts we saw. This data came from this table. And if you notice, this table is missing the other unknown category, representing people who didn't feel they fit into just one category, or they felt they fit into multiple categories, or who declined to respond. So if you have missing data like that, again, you can't use a pie chart. So if you notice at the bottom of the percent column, it adds up to 90.4% out of 100. So you can't use a pie chart for this. You have to use a different kind of visual representation for your data. Here are two examples of bar graphs. And again, 1.9, that's the bar graph with the other unknown category included. And then these are again by alphabetically, Asian, Black, Filipino, Hispanic, Native American, Pacific Islander, White, Other, Unknown. And then the next one, figure 1.10, that's the Pareto chart. So these bars are sorted in descending numerical order. So Asian was the largest category, down to Native American, the smallest category. So we're going to do a Pareto chart in Excel to show you how to do it. You want to start again by entering the data into two columns. One column is your label, the other column is your data. You'll notice in this picture, purple, that's the label, the blue is the data. That's when you highlight it and insert the chart. Excel colors it that way so you know what it's looking at, and you can see on the bottom the labels, and then each of the bar graphs represent the frequencies. This time we want to sort the data from largest to smallest because we want to do the Pareto chart. So actually we're going to do that, and then we'll select the two columns. Then we're going to insert chart and select the bar graph that you prefer. Once again, you can double click on items within the diagram to edit them. So now we're going to try it on your laptop. So this we're on the second tab now in Excel. See, it says Excel Pareto chart example. And again, I have my titles at the top of my chart, conditions that might cause lateness. So then I have all my causes here and the frequency that it was reported that was the cause that they were late. And again, it's alphabetical. Car trouble, finding something to wear, last minute studying, other, snoozing, etc. And then we have our frequencies. So if we highlight our data and we go back to insert, again, we can choose, like if we click on recommended charts, it'll give us some options of what they recommend, Excel recommends. You can choose one of those. It is a way to sort of look at the different ways your data would be displayed. Or if you know, right, we're doing a Pareto chart, so we know we want, in this case, they call them columns because they're vertical, bars go sideways, horizontally. So, again, whichever one shows it the way you want it to show it. I've done a vertical bar graph or column graph. Again, it gives me different formats up here, and you can choose the one you like. I think the one that I have in the video is just the standard one, but I can't remember. Again, you can double click on things and put a title in. It's always a good idea to put a title on your charts so that people know what they're looking at. So this is causes of lateness. Let's see, I don't think I spelled that right. Greatness. Okay, or you could put in more or less. Now, we wanted to do a Pareto chart. So this is not a Pareto chart where the bars are going in descending size order. So I am going to highlight my data again. You could do this first. You could sort the data first and then make your chart, but I just wanted to show you that you can do it this way as well. And again, we're going to sort. And so again, I don't want to sort by column A because that's the type, the cause of the trouble, not the frequency. I'm going to sort by column B, and I want to go again from largest to smallest. Click on OK. It sorted my table, and then it automatically changed my chart. So that was great. Again, you can highlight things like, say, I'm like, oh, I'm tired of that blue. What should I do for a fill? How about a nice bright green? That really stands out. I love that. It's totally up to you when you're doing stuff like that. If you click on your chart and you go back here to up top, it says chart design and format. There's other ways that you can edit your chart to make it look the way you want to. So again, in chart design, maybe you're like, you know what, I want to try one of those other chart formats. But see, it changed it back to that blue. So you can easily change the color, do whatever you want. But that's how you make a Pareto chart in Excel.